The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. Thank you for attending this afternoon's webinar on the new features of TopSolid 2021. This is session 3 for the day. We have one more at 3 o'clock this afternoon Central Time. In today's session, we're going to be going over some improvements to the Virtual Jog command, link movement command, and simulation. So let's go ahead and get started. Turn that off for the moment. Okay, so automatic part transfer or automatic WCS for part transfer. One of the new improvements this year has to do with part transfers. In 7.14 and before, you had to manually define a WCS to do your part transfer. In 7.15, we are doing our best to automatically detect this, provided a couple of criteria are met. First criteria is, and this is, by the way, this is for part pulling, part transfer, and approach to hold part. In 7.15, we're automatically creating the WCS. We search first for a drivable part support. If it doesn't exist, we search for a drivable part holder. Okay, so you have to make sure your machine or components are defined properly for this to function. Let's have our first look. Okay, so first things first, we have our turret is, parked normal. Now we want to do the part transfer, so we're going to go to the additional tab. We'll go up here to Virtual Jog. Let's go ahead and start by selecting our approach to hold part. Now, normally you would go ahead and do a hold release part first. Yeah, let's go ahead and do it. So we'll say hold release part. Let's release on the sub spindle. Perfect. You'd add a delay or a dwell if you need to. So now let's go ahead to approach to hold part. And here we rename some things as well, just to make it a little bit more obvious what it is. So switch from rapid to work feed rate at where? How about at 50 millimeters? Okay, and then here we want to hold the part by minus 10 millimeters. Now, as soon as we click OK, another improvement this year is we show asterisks on items that are missing. So here, for example, this movement requires cutting conditions. Perfect, so let's go activate cutting conditions. Okay, we can say 500 millimeters a minute, and that should be that. And then we can come here, we can simulate, and like that, you'll notice we didn't have to pick the WCS. The WCS was automatically selected because the machine was defined properly for it. If I go to my operational parameters here and I go to WCS in Origins Manager, you can see the new WCS was created. If I go to Edit, you can see what the tool holder is. It's the sub spindle, the part, and off we go. Okay. So in your machine definitions, they have to be defined correctly. The other thing I'll point out is in the machine components, they have to be defined correctly as well. So if we go into the machine component here, if you're creating a chuck that's a machine component, make sure it's described as a drivable part support and that you have the mounting frame and the drivable frame specified correctly. Okay, so this was an improvement from 7.14 last year, so drivable accessory frame. This is here, and the mountable frame to put on the machine is that frame. Okay, with those then, the automatic WCS should be recognizable by the solution, which saves you time and makes it faster to work on. Okay, so moving right along, there was a couple of other things I forgot to mention, so I'm going to bring my little cheat sheet over here. We changed a couple of user interface objects as well, just to simplify things. In 7.14, with regards to activating G-code, activating simulation, there was a little checkbox in there. We switched it to a drop-down menu to be consistent with the rest of the interface. Everything is changing to these drop-down icon menus. Okay. Same thing for feed rate, frame, RTCP, and so forth. It's the way it was. Okay, so 7.14, and now in 7.15, we now have the drop-down icon bars. Okay. So I see a question: if the machine definition and/or component are defined properly in 7.14, are there any changes needed for 7.15? With regards to part transfer, no, I don't believe there is. If they're defined properly, then we use those same properties. All the properties I was pointing out existed in 7.14. Now the virtual jog is using them better or automatically for part transfer. Okay. All right, so what's next? Automatic selection of part and tool. So this one's pretty straightforward. If you go into a virtual jog, when we create a virtual jog without a part, with a part, but now we open the geometry tab, we will only have, and we only have one part in the file. TopSolid'Cam will select that part. Sorry, I moved something in my way here. So if I go and create a virtual jog, let's go do that. If I go to geometry, you'll notice that it's automatically selected. Okay. Same thing is if I go to tool. So if I go and select a tool here, TopSolid is going to automatically pre-select now the previously used tool in the previous operation. In 7.14, this wasn't the case. You had to manually go in and select that tool or whatever tool you want to use. So little but functional improvements. All right, next point. So a better way to select a tool change position. Okay. So if we look at this in here, you'll notice we have a tool change position called here. And here, let's go and just delete this and we'll do it again. So if we go to tool change position, if I go to my movement here and I go to tool change position or tool change motion, notice it says no tool holder and part holder defined for this operation. Okay, so we're missing something. What are we missing? Well, we're missing a WCS and we're missing a tool. So we would need to pick a tool. So there's our tool. Now we need to pick a WCS. There's our WCS. And then you can choose which motion you want. Okay. Alrighty. Perfect. Let's keep on going. The next one, it has to do with turret indexing and point motion. Here we go. Oh, this one. Okay. I'm just going to bring my cheat sheet over for this. Basically, we made an improvement so that Virtual Jog was aware now if there's a turret present or if there's not. So in the case of a mill, you won't see the turret indexing option anymore. So you can't accidentally try to drive something that doesn't exist. There's a slight oversight on our side. If it's a turning machine and there's at least one turret, then the turret indexing will show up. Alrighty. Oops, that's not what I wanted. One second. Go down to Virtual Jog. Move that back out of the way. Alrighty. Perfect. All right, so now we're on to link movements. So first link movement we'll talk about, this one's kind of cool, is a new option within link movements. So I'm going to tap F4 here. This is the icon right here, add along tool motion. Okay, so what this means is it will move based on the orientation of the tool axis. If we have this set to none, it's going to move however much you set here. If I have it set to max, it will go to the max stroke of that axis. Depending on the machine or the control you're using, then this will control or call the specific types of movements. For example, if I bring my cheat sheet back over here, if I'm going to 200, like the sample showed, and we're on a Heidenhain control, it'll call the M140 MB, 200. If we call the max, then it'll call the MB max command. So it just depends on the control over how it's going to call code. Cool. All right, let's go to the next one. Using security shape for approach. So in 7.14 and prior, you could not use the security shape for an approach movement. Okay, it just never saw an intersection. Now you can, and we've added a little checkbox to make this possible. So here we want to modify the approach. All right, so let's zoom up on this here. And here you see we're setting the B and the S axis. Okay, now we're going to move in Z. And then here is the movement to security shape. So you can add the security shape, and this is the new option right here, force movement to shape. If we uncheck it, nothing happens. If we check it, it allows it, once the tool is in a place where it can intersect with the shape, it will function. If I move this up above this, there's nothing for it to intersect to, unless I brought the tool down in Z first, then it could approach that way. Okay, so that's that command. Next, we have a new command on turning machines for manual retract movement with collisions. So for example, this tool path here, if I go and edit the retract, or the interop, I should say. No, it's a single tool, so edit retract. So here you see a check collision command. I'm going to delete that. So here we're pulling out, that's pulling straight out right now. So instead what we want to do is we want to activate this new command, which checks the collision and inserts points automatically to move to. Okay. Once you validate that you have that in there, if you want to we need to retract. If you want to, you can extract generated elements and get rid of the check collision option. So we leave the points behind so it's still safe. Okay. Then you can delete the points as well if you want. So that's how that new command works. So I see a question there, meaning the retract along tool axis, can it call specific machine cycles? I believe the answer is yes. We'll have to check that on your machine to be sure. The sample I gave was in the Heidenhain base. If we can do it in the Heidenhain base, I don't see why we couldn't do it in the Siemens base. So we'll just have to check and try it. Okay, so that's the check collisions. And move on to the next one here. So next we're going to talk about the renaming, deleting, and replacing of saved link movement files. Okay, and I'm going to run a video for this one. So we'll just go into a CAM file, and we're going to talk about how you save link movements really quick, and then how you can rename them, delete them. So we go ahead and edit a link movement. We have a custom link movement. We're going to hit save. and give it a name. 221, why not? Okay. Now that's saved. We want to go and edit a link movement again. So we're going to go to save again. And this time you see 221 up there. If you select it and hit OK, it's going to ask you, do you want to replace it? Yes or no. If you choose no, it indexes it up with another 1 in parentheses like that. You can, of course, rename. You can show it in Project Tree over there. You can delete from that menu. From the project tree, you can set it obsolete as well, so it can't be used anymore. Okay, so now this is going to be called row 2. Okay, and now that one we want to delete. And that's the gist of it. So just cleaned up a little bit how we work with those objects. All right, next. No tool change position movement. So I'm going to run the simulation on this once, and then we're going to talk about it. So in this case, we have a gang holder. Okay, so this gang holder is a machine component. It has a tip drill, a drill, and a tap on it. In the versions past, if you did this, you had to really play with your link movements to stop this from going to tool change position in between operations. Now, the software is smart enough to realize the type of tool that's there. Okay, so let me get this thing set up, and we will start it again, but we'll slow this down. And of course, I went blowing right past it. So there's your tip drill. Notice it goes straight to the drill and then the tap. So no link movements needed. Is no tool change motion automatic or selectable? It's automatic in this case. Let's have a look. So first things first, the machine component needs to be selected as a tool mounting system. Okay, so accessory type, it's important. The turning machine must also have a y-axis. Okay, so I don't know if the half index will work on this one because I've not tried it on one without a y-axis, but here it's saying the conditions, it must have a y-axis. So my guess is it will still go to a tool change position for the half indexes. In that case, you'd be back to editing your link movements to move it where you want it to move. Okay. Then in the cam file, we have the 3 tool positions as we showed, and that's it. Okay. Here we can go look at the component really quick if you like. Just to illustrate this again, tool mounting system, super duper important. Mountable accessories. So here, this is your mounting frame here that gets in the turret. And then these are each of the tool holders, and you can see this holds tools on both sides. So make sure those are defined properly, and you're good to go. All right. Move this back over. So link movement rules, actually. I'm going to bring my sheet back because we're just going to talk about them here for the moment. So for those of you that have played with link movements, we have added a bunch of new tests or rules that you can test link movements on to auto apply them on. So first of all, you can have a specific test now for start and end program. So you can say tool holder is spindle. Okay, if it's the program start is yes, then apply this approach move. If it's the program end, then apply this retract move. This is especially great for those of you who want a different type of retract when it's the end of program. This way you can specifically say, use this link movement at end of program, use this safe approach at beginning of program. Okay. Next, you can force loading an interop. This point is only for interoperations. Until now, there was no WCS change. In reality, no rotation of head and or plate and no change of part holder between the two operations. Link movement defines in the rule document was systematically ignored and automatic interoperations was performed. There's now an option in the link movement rules document that allows you to force interoperation loadings, even if there's no head and or part rotation between the two operations. That's all. So it's just to say when no other condition is met, force this to happen. That's the simplicity of what this is. Okay. Next, we can run a test on part change. So we want to do this interoperation or this link movement if the part that we're machining is changing. Okay. A good example of this. Let's go to change orientation. Okay. Same thing with the orientation changes. So here, this link movement was applied because we're going from this operation to this operation, which is a different part. So it's applying automatically a specific link movement based on the fact that orientation is changing. Okay, that's another one of the improvements. If we go to part change, okay, similar sample, but now no orientation change, it's just physically part change. So what do you want to do when the part changes? We want it to go to here, and then down, okay? So you have the ability now to test on both of those within a link movement rules document. Change part, if the origin changes, if the orientation changes, great for horizontal machining, okay? Another little improvement here is that you have the ability to add a PP word directly in a link movement. This can be handy for certain machines. This could be a way to call a specific cycle for a link movement style on the machine. If it's not something our base post processor supports directly, maybe it's some weird thing that the machine can do, we can call this, okay? Or you could use the PP word to call the robot to come in and begin its move to start coming in to grab the part or whatever. Any number of things you could use a PP word for at this moment in time, but this allows us to call that PP word at the very specific point in that link movement, okay? All right, a couple of other quick points. We have a little improvement to simulation, speed coefficient for rapid movements. Let's go look. I suppose we could have done it in that one or this one as well, but I'll open up the sample. Why not? Okay, so here is we'll look at it here. First of all, you have to be in time increment, okay? The improvement is you have a speed for rapid movements now, okay? So I can have my rapid movements running very slow. Okay, or I could have my rapid movements running very fast. So in between our cycle moves there, and you're gonna see, boom, it just hops over there. So you have to be in the time increment for this to get this improvement. And then finally, this is an improvement inside of Verify. In the general settings of Verify, you now have a tolerance for the machine itself. So you have a faceting tolerance for the machine. So if you have a very detailed machine and you're okay with loosening up the tolerance just to win on some calculation time, you now have control over that. And I believe that's it. Let's see. I see some questions there. I'm just reading through them real quick to see if these are anything that I can answer right now. Let's see. Okay. How about acceleration factor for more accurate time estimates? I know that it's something that the development team has been working on. I believe that the TopSolid Cam Simul product with the Optimize, I believe that does some acceleration, deceleration calculations for cycle times as well. So when that product is officially released in SP4, we can maybe try to plan a webinar about TopSolid'Cam Simul to talk about all of those things. Okay. Okay, beyond that, we have one more webinar today to cover some miscellaneous things. The next webinar at 3 p.m. Central Time will cover methods. There's 14 improvements there. Machinable property, some global fitting with multiple intersections, Makino interface, I believe, for wire EDM, and machine preview and position, some other little things. So if there's no other questions, then we will wait and talk to you guys then. Have a good afternoon until then.